Hello everyone, welcome back to my channel. I am Yashwardhan, currently pursuing my education in Sri Venkateswara College of Engineering of Department CSE Cybersecurity. In this video, we are going to discuss about recursion in Java. Introduction to recursion. What is recursion? A recursion is a programming technique where a method calls itself to solve a problem. It is a powerful tool for solving complex problems by breaking them down into smaller, more manageable subproblems. Recursion involves a base class that terminates the recursive calls class and calls the method again with a smaller input. To implement recursion, we must ensure two things: a base case to terminate the recursion and a recursive call that breaks down the problem. Example of a recursive method. A classic example of recursion is the factorial function. The factorial of a non-negative integer n is the product of all positive integers less than or equal to n. The factorial function can be defined recursively as f of n equals n. Advantages of recursion. Recursion allows for elegant and concise solutions to problems. It can simplify the implementation of complex algorithms by breaking them down into smaller, more manageable parts. Recursion can often lead to code that is easier to understand and maintain. Recursive solutions often follow a divide and conquer approach, breaking them into a smaller problem, more manageable subproblems. This can simplify complex tasks. Some problems inherently exhibit recursive structures, and solving them using recursion aligns well with their nature. Example include tree traversal and certain mathematical calculations. Disadvantages of recursion. Recursive methods can be less efficient compared to iterative solutions. They may consume more memory and result in a higher number of method calls. Recursive algorithms can be harder to debug and understand for beginners. Recursive functions rely on the call stack, and deep or infinite recursion can lead to a stack overflow, causing the problem to crash. This is a potential concern, especially when dealing with the larger datasets. While recursion enhances readability for many, some developers may find it challenging to understand or debug recursive code. It requires a good understanding of the base class and the recursive step. Recursive calls involve the overhead of function calls, which may be less efficient than iterative approaches for some languages or platforms. Next, tile recursion. Tile recursion is a special type of recursion where the recursive call is the last operation performed in the method. In tile recursion, the result of a recursive call is directly returned without an additional computation. Tile recursion can be optimized by the Java compiler to use iteration instead, resulting in a improved performance. Tile recursion is a specific form of recursion where the recursive call is the last operation performed in a function. In other words, the result of the recursive call is immediately returned without further computation or processing. The key feature of tile recursion is that the recursive call is in the tail position of the function, allowing certain compilers to interpreters to perform a optimization known as tile call optimization or tile call elimination. Indirect recursion. Indirect recursion occurs when method A calls method B and method B calls method A. This type of recursion can be used to solve problems that require mutual recursion. Indirect recursion can be a powerful technique, but it requires careful design and understanding of the problem. Indirect recursion occurs when two or more functions call each other in a circular manner, forming a cycle of function calls. Unlike direct recursion, where a function calls itself, indirect recursion involves multiple functions calling each other in a loop. This creates a chain of functions calls that eventually leads back to the initial function. Recursive data structure. Used to define and manipulate recursive list. Recursion can be used to define and manipulate recursive data structures such as linked lists and trees. Recursive data structures have a hierarchical nature where each element can contain references to each other elements of the same type. Recursive algorithms can be used to traverse, search, insert, or remove elements from recursive data structures. Tile call optimization. Tile call optimization is a compiler optimization technique that converts tile recursive method into iterative loops. It eliminates the need for additional stack frames, improving performance and reducing memory consumption. Java does not natively support tile call optimization, but some functional programming languages do. Common pitfalls in recursion. Infinite recursion occurs when a recursive method does not have a base case or the base case is never reached. Stack overflow can occur if a recursive method has too many nested calls exceeding the maximum stack size. Careful attention should be given to designing and testing recursive methods to avoid these pitfalls. Lack of base class, that is, forgetting to define a base case, can lead to infinite recursion, causing the problem to run indefinitely. Always ensure there is a condition to terminate the recursion. Incorrect base case. If the base case is not properly defined or doesn't cover all possible scenarios, can result in incorrect or unexpected behavior. Guidelines for using recursion. Identify the base case and ensure they are correctly implemented. Verify that a recursive case correctly reduces the problem to smaller subproblem. Test the recursive method with different input values to ensure it terminates. When a problem can be naturally divided into smaller, more manageable subproblems, recursion is a good fit. Each recursion call addresses a subset of the original problem. If the problem exhibits a self-similar or self-repeating structure where the same pattern repeats at different scales, recursion is often an elegant solution. Recursion can lead to more concise and readable code, especially for the problems that have a recursive nature. It mirrors the problem solving. Conclusion. In conclusion, recursive is a more powerful programming technique with both advantages and disadvantages. Its suitability depends on the nature of the problem at hand. Recursive excels in scenarios where problems can be naturally divided into smaller, self similar sub problems and exhibit a divide and conquer structure. It promotes clean, elegant, and readable code, particularly for problems with recursive characters. However, recursion comes with potential pitfalls, including the risk of stack overflow, inefficient memory usage, and difficulties in understanding. For some developers, it's crucial to define and handle base cases properly, avoid unnecessary recalculations, and mindful of stack related issues. Before choosing recursion, carefully consider the problem requirements, potential performance implement, implications, and readability of the code. In some cases, an iterative approach might be more efficient and easier to comprehend. By understanding the strengths and limitations of recursion, we can leverage it effectively to solve complex problems while minimizing the associated risks. Thank you.